So earlier in section 2, where we talked about nodes module system, you learned about this HTTP module. We use this to create a web server that listens on port 3000 and responds to requests to these endpoints, so the root or /API/courses. Now, while this approach is perfectly fine, it's not ideal for building a complex application. Because in a large complex application, we might have various endpoints, and we don't want to hard code all these if statements in this function. So in this section, we're going to look at Express, which is a fast and lightweight framework for building web applications. So next, we're going to look at RESTful services. Let's start this section by a brief introduction to RESTful services, also called RESTful APIs. If you already know what REST is all about, feel free to skip this video. So earlier at the beginning of the course, I introduced you to the client-server architecture. So most, if not all applications we use these days follow this architecture. The app itself is the client or the front-end part. Under the hood, it needs to talk to the server or the backend to get or save the data. This communication happens using the HTTP protocol, the same protocol that powers our web. So on the server, we expose a bunch of services that are accessible via the HTTP protocol. The client can then directly call these services by sending HTTP requests. Now, this is where REST comes into the picture. REST is short for representational state transfer, and I know it probably doesn't make any sense to you, because it was introduced by a PhD student as part of his thesis. But the theory aside, REST is basically a convention for building these HTTP services. So we use simple HTTP protocol principles to provide support to create, read, update, and delete data. We refer to these operations all together as CRUD operations. Now let's explore this convention using a real-world example. Let's say we have a company called Vidly for renting out movies. We have a client app where we manage the list of our customers. On the server, we should expose a service at an endpoint like this. So vidly.com/API/customers. So the client can send HTTP requests to this endpoint to talk to our service. Now, a few things about this endpoint you need to know. First of all, the address can start with HTTP or HTTPS. That depends on the application and its requirements. If you want the data to be exchanged on a secure channel, you would use HTTPS. After that, we have the domain of the application. Next, we have /API. This is not compulsory, but you see a lot of companies follow this convention to expose their RESTful services. They include the word API somewhere in the address. It can be after the domain, or it can be a subdomain like api.vidly.com. There is no hard and fast rule. After that, we have /customers, which refers to the collection of customers in our application. In the REST world, we refer to this part as a resource. We can expose our resources, such as customers, movies, rentals, on various endpoints. So this is our endpoint to work with the customers. All the operations around customers, such as creating a customer or updating a customer, would be done by sending an HTTP request to this endpoint. The type of the HTTP request determines the kind of the operation. So every HTTP request has what we call a verb or a method that determines its type or intention. Here are the standard HTTP methods. We have get for getting data, post for creating data, put for updating data, and delete for deleting data. Now let's explore each of these using our customers example. To get the list of all customers, we should send an HTTP GET request to this address. Note the plural name customers here. It indicates a list of customers. So when we send an HTTP GET request to this endpoint, our service should send us something like this. So we have an array of customer objects. If we want a single customer, we should include the ID of that customer in the address. Then our server would respond with a customer object like this. Now, to update a customer, we should send an HTTP put request to this endpoint. And note that again here, we're specifying the ID of the customer to be updated. But also, we should include the customer object in the body of the request. So this is a complete representation of the customer object with updated properties. We send this to the server, and the server updates the customer with the given ID according to these values. Similarly, to delete a customer, we should send an HTTP delete request to this endpoint. But here we don't need to include the customer object in the body of the request because all we need to delete a customer is an ID. And finally, to create a customer, we need to send an HTTP post request to this endpoint. Note that here, because we're adding a new customer, we're not dealing with a specific customer, so we don't have the ID in the address. We're working with the collection of customers, so we're posting a new customer to this collection. And that's why we should include the customer object in the body of the request. The server gets this object and creates the customer for us. So this is the RESTful convention. We expose our resources, such as customers, using a simple, meaningful address, and support various operations around them, such as creating or updating them, using standard HTTP methods. So throughout this section, you're going to learn how to use the Express framework to build a RESTful service for managing the list of customers. However, in this section, we won't be doing any database work because that will bring in additional complexity. Our focus will be purely on building HTTP services, and we will use a simple array in memory to keep the list of our customers. Later in the course, we'll look at using a database. So here's the code that we wrote in the section about Node Core, where I introduce you to the HTTP module. So you can see with HTTP module, we can create a web server. Here we have a callback function that takes two parameters, request and response. And with this request object, we can check the URL of the incoming request. So with this, we can define various routes for our application. So if you have a request for, let's say, /API/courses, this is how we're going to respond to the client. Now, while this approach certainly works, it's not very maintainable because as we define more routes for our application, we need to add more if blocks in this callback function. So that's when a framework comes into the picture. A framework gives our application a proper structure, so we can easily add more routes while keeping our application code maintainable. Now, there are various frameworks out there for building web applications and web servers on top of Node. The most popular one is Express. So if you head over to npmjs.org or npmjs.com, here, let's search for Express. So the current version is version 4.16.2. Let's have a quick look here. So here on the right side, look at the statistics. There have been over 700,000 downloads in the last day and over 15 million downloads in the last month. It's a very popular framework. It's also very fast, lightweight, and perfectly documented. So now back in the terminal, let's create a new folder for this section. So I'm going to call this Express Demo. Now let's go inside this folder, run npm init with yes flag. So now we have a package.json file. And finally, we can install Express. Beautiful. In the next lecture, I'm going to show you how to build your first web server using Express. All right, now in VS Code, let's add a new file, index.js. We could also call it app.js. It doesn't really matter. So in this file, first we want to load the Express module. So we use our require function, give it the name of our module, which is Express. Now this returns a function. We call that Express. Okay? Now we need to call this function like this. And as you can see, this returns an object of type Express. By convention, we call this object app. So we store the result in a constant called app. So this represents our application. Now this app object has a bunch of useful methods. we have methods like get, post, put, and delete. All these methods correspond to HTTP verbs or HTTP methods that I told you about earlier in this section. So if you want to handle an HTTP post request to an endpoint, you would use app.post. Now in this lecture, we just want to use app.get. We want to implement a couple of endpoints that respond to an HTTP GET request. So this method takes two arguments. The first argument is the path or the URL. So here I'm going to use slash to represent the root of the website. Now the second argument is a callback function. This is the function that will be called when we have an HTTP GET request to this endpoint. Okay, so this callback function should have two arguments, request and response. So this goes to a code block. Now this request object has a bunch of useful properties that gives us information about the incoming request. If you want to learn about all these properties, it's best to look at the Express documentation because in this course, we're going to use only a handful of these properties. So head over to expressjs.com. On the top, look at the API reference, version 4. Now here you can see the request object. And below that, you can see all the properties that are available to you. We have base URL, we have body to read the body of the request, cookies, fresh, hostname, IP, method, original URL, parameters, and so on. So back to our code. When we get an HTTP GET request to the root of our website, we're going to respond with a hello world message. So response.send hello world. So this is how we define a route. We specify the path or the URL and a callback function, which is also called a route handler. Now, finally, we need to listen on a given port. So we call app.listen. We give it a port number like 3000, and optionally, we can pass a function that will be called when the application starts listening on the given port. So once again, we use the arrow function syntax to display something on the console. So console.log listening on port 3000. Now back in the terminal, node index.js. Okay, we're listening on port 3000. Now let's switch over to Chrome and go to localhost port 3000. So here's our hello world message. Now let's define another route. So once again, we're going to call app.get. Now this one is going to be /API/courses. Once again, we pass a function with two arguments, that is request and response. And this goes to a code block. Now, in the real world scenario, here we want to get the list of courses from the database and return them. But as I told you before, in this section, our focus is purely on building these endpoints. We're not going to do any database work. So I'm going to simply return an array of numbers. So response.send, we pass an array of 3 numbers. In the future, we can replace these numbers with actual course objects. So save. Now back in the terminal, we have to stop this process and start it again. So press Ctrl and C. Okay, one more time, node index.js. Now back in Chrome, let's head over to /API/courses. Look, we have an array of 3 numbers. Beautiful. So this is what I want you to pay attention to here. In this implementation, we don't have those if blocks. We define new routes by calling app.get. And with this structure, as our application grows, we can move some of these routes to different files. For example, we can move all the routes related to courses to a separate file like courses.js. So Express gives our application a skeleton, a structure. So far, you have noticed that every time we make a change to this code, we have to go back in the terminal and stop this process and start it again. This is very tedious. So I'm going to show you a better way. We're going to install a node package called nodemon, which is short for node monitor. So in the terminal, npm install -g, because we want to install this globally so we can run it anywhere. And the name of the package is nodemon. Now, as I told you before, if you're on Mac and you haven't configured the permissions properly, you need to put sudo at the front. All right, nodemon is installed. So with this, instead of running our application using node, we use nodemon. Okay? Now you can see nodemon is watching all the files in this folder, any files with any extensions. So if you come back here and make a simple change and then save the file, now look in the terminal, nodemon restarted our application or our process due to changes. So we don't have to do this manually anymore. Now, back in the browser, if we send a request to the root of the website, we can see our new message displayed here. Now, one thing we need to improve in this code is this hard-coded value for the port. So we have used 3000 as an arbitrary number. While this may work on your development machine, it's unlikely that this is going to work in a production environment. Because when you deploy this application to a hosting environment, the port is dynamically assigned by the hosting environment. So we can't rely on 3000 to be available. So the way to fix this is by using an environment variable. So typically in hosting environments for node applications, we have this environment variable called port. An environment variable is basically a variable that is part of the environment in which a process runs. Its value is set outside this application. I'm going to show you how that works in a second. So in this application, we need to read the value of this port environment variable. And the way we do that is by using the process object. So we have this global object called process. This object has a property called env, which is short for environment variables. And after that, we add the name of our environment variable, in this case, port. So if this is set, we're going to use this. Otherwise, we're going to use 3000. Now we can store the result in a constant called port. Okay, let's delete this. And finally, we need to replace 3000 with port and also change our message accordingly. So I'm going to replace the single quote with backtick, so we can use a template string. And here we're going to replace 3000 with a dynamic value. So we add $, curly braces, and then add our constant, in this case, port. Okay, now back in the terminal, let's run this application using nodemon. So on this machine, you can see I don't have an environment variable called port. That's why 3000 is used as the port for this web server. Now I'm going to set an environment variable. So let's stop this process. On Mac, we can set an environment variable by executing the export command. If you're on Windows, you should use set. So export or set. Now we add the name of the environment variable, in this case port, and set its value. I'm going to use 5000. So now we have this environment variable called port with the value of 5000. With this, when we run this application, nodemon, you can see that now we are listening on port 5000. So this is the proper way to assign a port to your node applications. You should attempt to read the value of an environment variable called port. If there is a value, you should use that. Otherwise, use an arbitrary number for your development machine. All right, so currently we have a route for getting the list of courses. Now in this lecture, I'm going to show you how to create a route to get a single course. So earlier in the section where I talked about RESTful services, you learned that in order to get a single course, we should include the ID of the course in the URL. So our endpoint should be like this, /API/courses/1, assuming that 1 is the ID of the course. So let's see how we can implement a route like this. So app.get, we add the path, that is /API/courses. Now here we need to define a parameter. So we add colon and ID. So ID is the name of our parameter here. We could use anything. It doesn't have to be ID. It could be course ID. But ID is shorter and more conventional. Now we add our route handler function. So request and response goes to. Now, in order to read this parameter, we use request.params.id. So for now, let's just send this to the client. So resource.send. Okay, back in the browser. Now let's head over to /API/courses/1. So you can see we successfully read the value of this parameter. Also, it is possible to have multiple parameters in a route. For example, imagine you're building a service for powering a blog. So we could have a route like this: posts, year, month. So we have 2 parameters, and with this, we can get all the posts for the given month and the given year. Now, we can read these parameters just like before. So request.params.year or month. For this demo, let me show you this request.params object. So let's delete this, save, back in the browser. Now let's head over to API, posts, 2018, and 1. So this is our request params object. We have 2 properties, year and month, and they're named based on our route parameters. With Express, we can also get query string parameters. These are parameters that we add in the URL after a question mark. For example, we can get all the posts in January 2018 and sort them by their name. So we add a question mark, sort by, set this to name. This is a query string parameter. We use query string parameters to provide additional data to our backend services. So we use route parameters for essential or required values, whereas we use query string parameters for anything that is optional. Now let me show you how to read query parameters. So back in VS Code, instead of request.params, we use request.query. Save, back in Chrome, and this is what we get. So query parameters are stored in an object with a bunch of key value pairs. All right, now let's implement a new endpoint to get a single course from the server. So first of all, let's change this back to courses and add the ID parameter here. Okay, now on the top, let's define an array called courses. So constant courses, we set this to an array. And in this array, we're going to have 3 course objects. So each object should have a couple of properties, ID and name. And of course, we can have more, but for simplicity, I'm just going to stick to 2 properties here. Okay, now let's duplicate this line and change the IDs as well as the name, 2 and 3. So we have 2 endpoints, one to get all the courses and the other to get a single course, right? In the first one, we're going to return our courses array, okay? Now in the second one, we should write some logic to look for the course with the given ID. So let me delete this first. We're going to call courses.find. This is a method that is available on every array in JavaScript. As an argument to this method, we need to pass a function. This function will be used to find a course that matches a given criteria. So we use the arrow function syntax, C goes to, and here we write some logic that returns a Boolean value. This Boolean value determines if this course is the one we're looking for or not. So c.id should equal request.params.id. However, this request.params.id returns a string. So in order for this comparison to work properly, we need to parse this string into an integer. So we call parseInt, which is one of the global functions available in JavaScript, and then get the result and store it in a constant called course. Now you might be asking why I didn't use var here. Well, that would be perfectly fine, and that's how most JavaScript code out there is written. But going forward, it's best to drop var and either use let or const. We use let if you want to define a variable that we can reset later, and we use const if you want to define a constant. In this case, I don't want to reset the course later in this function. But again, that's perfectly fine to use let here as well. It's just personal preference. So we get the course object. Now, if this course doesn't have a value, in other words, if we don't find a course with the given ID, by convention, we should return a response with the HTTP status code of 404. That means object not found. So this is one of the conventions of RESTful APIs. If the client asks for a resource, but that resource does not exist on the server, we should return a response with the status code of 404. So here we call response.status 404, and optionally we can send a message to the client as well. So send the course with the given ID was not found. Okay. Now, otherwise, if we do have a course with that ID, we're simply going to return that to the client. So response.send course. Now let's test this. So back in the browser, let's head over to /API/courses/1. So we have a course with the ID 1, and that's why we get this JSON object in the response. However, if I change this to 10, we get this message: the course with the given ID was not found. And to ensure that the status code of this response is 404, we can open up Chrome Developer Tool. So right click here, go to inspect, and then on the network tab, make sure you don't have a filter here. So select all, and then refresh the page by pressing Ctrl R on Windows or Command R on Mac. So here's a request that we sent to the server. You can see the status is 404, which means not found. So far, we have created two routes that respond to HTTP GET requests. And we use these routes to get all the courses as well as a single course. In this lecture, I'm going to teach you how to respond to HTTP POST requests. So we use an HTTP POST request to create a new course. So app.post, instead of the get method, we use the post method. Now, similar to the get method, we need to specify a path. So that should be /API/courses, because we're going to post to the collection of courses. That's why we use the plural name here. Then we add our route handler. So request and response goes to code block. Now I'm going to add some line break here so I can easily see this video. All right. So in this route handler, we need to read the course object that should be in the body of the request, use its properties to create a new course object, and then add that course object to our courses array. So let's create a new course object, constant course. Again, I'm using a const here because we're not going to reset this course object later. So let's set this to a new object. Now here, because we are not working with a database, we need to manually assign an ID. So ID. So we get the number of elements in our courses array. So courses.length, and simply add 1 to it. In the future, when we work with a database, the ID will be assigned by the database. Next is the name property. Now we need to read this from the body of the request. So request.body.name. So here I'm assuming that in the request body, we have an object, and that object has a name property. Now, in order for this line to work, we need to enable parsing of JSON objects in the body of the request, because by default, this feature is not enabled in Express. So on the top, after we get the app object, we need to call app.use, and here we call express.json. Now, this may look a little bit strange or unfamiliar to you, but don't worry. Later in this section, we're going to explore this in detail. Basically, what we're doing here is adding a piece of middleware. So when we call express.json method, this method returns a piece of middleware, and then we call app.use to use that middleware in the request processing pipeline. Again, we're going to explore that in detail later in the section. So back to our new route handler. We have a course object. Next, we push it in our array. So courses.push course. And finally, by convention, when we post an object to the server, when the server creates a new object or a new resource, it should return that object in the body of the response. So response.send course. The reason for this is because we're assigning this ID on the server. So we need to return this course object to the client because chances are the client needs to know the ID of this new object or this new resource. So this is how we handle HTTP post requests. In the next lecture, I'm going to show you how to test this endpoint. All right, to call HTTP services, we use a Chrome extension called Postman. So if you haven't installed Postman before, search for Chrome Postman. Here's Postman. Simply add it to Chrome. Okay, done. Now you can open this from the apps menu here. Postman. Now here it's asking you to sign up for an account, but you don't have to do this. There's a link here taking me straight to the app. All right, now on this page, we can create a new HTTP request. So from this drop-down list, we set the type to a post request. We put the URL here. In this case, that's HTTP localhost. On my machine, I'm using port 3000 to host this application. API/courses. Now, we need to set the body of this request. From this list, select raw, and then JSON. So with this, we can put a JSON object in the body of the request. So let's add an object here and give it a name property. So name, we set this to new course. And then finally, send. Okay, if you scroll down, you can see the status of the request is 200, which means the request was handled successfully. And here's the body of the response. So ID is 4, because now we have 4 courses in our array, and this is the same name that we sent to the server. So this is how we test HTTP services using Postman. Now, in this implementation, we have assumed that there is an object with the name property in the body of the request. What if the client forgets to send this property or sends an invalid name, perhaps a name that is too short? That's where input validation comes into the picture, and that's the topic for the next lecture. In this lecture, I'm going to show you how to do input validation. So as a security best practice, you should never, ever, ever trust what the client sends you. You should always validate the input. So in this particular example, because we're dealing with a simple object with only one property, that is name, we can write some validation logic like this. So if request.body.name doesn't exist, or request.body.name.length is less than 3, then we're going to return an error to the client. The RESTful convention is to return a response with the HTTP status code of 400. That means bad request. So to do this, we call response.status 400, and then we can send an error message. In this case, we can write a generic error message like name is required and should be minimum 3 characters. Now in your implementation, you may want to differentiate the errors. For example, if the client didn't send the name property, perhaps you would just respond with name is required. Or if they did send the name, but the name was not long enough, you could send a different error message. And then finally, we return here because we don't want the rest of this function to be executed. So this is the basic idea. However, in a real-world application, it's more likely that you will be working with a complex object, something more complex than this course object here. You don't want to write a complex validation logic like this at the beginning of your route handler. So let me introduce you to a node package that makes it really easy for you to validate the input. So on Google, if you search for npm joy with I, look, here's the first link. So here you can see Joy has been downloaded over 250,000 times over the past day and over 3 million times over the past month. It's a very popular package. Also here on this page, you can see some sample code and link to their official documentation. Now let me show you how to replace this validation logic with Joy. So first, back in the terminal, let's install Joy. So you can see at the time of recording this video, the latest version is version 13.1.0. If you want to make sure that you have the exact same experience as what I'm going to show you in this video, then install this exact version. So npm install joy at 13.1.0. Okay. Now back in the code, on the top, we need to load this module. So require joy, get the result and store it in a constant called joy with a capital J. Because what is returned from this module is a class. And as I told you before, in JavaScript, we use Pascal naming convention to name our classes. So the first letter of every word should be uppercase. Also, as a best practice, put all your required calls on top of the file. This way you can easily see what are the dependencies of this module. So this module, index module, is dependent upon two modules. One is joy, the other is express. Okay, so we have this joy class. Now back in our route handler. Now with joy, first we need to define a schema. A schema defines the shape of our objects. What properties do we have in that object? What is the type of each property? Do we have an email? Do we have a string? What are the minimum or maximum number of characters? Do we have a number? What range should that number be in? So this is the job of a schema. So here, first I'm going to define a schema. Constant schema. We set it to an object. This is the shape of our course object. So here we want to have a name property. And we set this to joy.string. So we're telling Joy that this is a string and it should have minimum 3 characters and it should be required. So it has a very fluent API. Again, you can look at the documentation to see all the methods that are available to you. So here's our schema. Now we call joy.validate and we give it request.body as well as our schema. Now this validate method returns an object. Let's store that in a constant called result. For this demo, I'm going to log this result on the console. So before we go any further, let's save this. Go back to the Postman. Let's create another course. Now back in the terminal. So this is our result object. It has 2 properties, error and value. Only one of these can have a value. So in this case, because we sent a valid course object, we have that object here as the value of the value property. And you can see error is null. If we send an invalid object, value will be null and error will be set. Let me show you. So back in Postman, let's remove the name property, send. Now back in the terminal. Okay, look. So here's the result object. This is the error property. It's set to an object that has validation error. Child name fails because name is required. So back to a route handler. Instead of this manual validation logic, we can check the value of result.error property. So if result.error, Then we're going to send a response with status code of 400. And in the body of the response, for now, we can simply add result.error. Okay? And we don't need this console.log anymore. Save. Now back in Postman, one more time, I'm going to send this empty object. Now look at the response. So this is what we get. An object with these properties is joy, name, details, which is an array of error messages. So here's the first message, name is required. Now this object is too complex to send to the client. Perhaps you want to simplify this. So back in the code, one simple solution is to go to the details array, get the first element, and then access the message property. Or instead of using the first element, you may want to access all elements in this array, get their message property, and concatenate them. That's entirely up to you. So save, one more time. Let's send an invalid request, and now we get name is required. If we go to our request and add the name property, but set it to a string that is only one character, now we get a different error. Name length must be at least 3 characters long. So you can see Joy makes it really easy to validate the input and return proper error messages to the client. All right, now let's see how we can update a course. So let's add a new route handler. App, we use the put method for updating resources. Now the path should be /API/courses. And here we need a route parameter because we're dealing with a specific course. So ID. Now our route handler function, request and response, goes to a code block. All right, now here's the logic we need to implement. First, we need to look up this course with this given ID. So look up the course. If the course doesn't exist, if not existing, we need to return 404. That means resource not found. Otherwise, we need to validate the course, make sure it's in good shape. If invalid, we need to return a 400 error, which means bad request. And if we get here, that means everything is good. So we update the course and return the updated course to the client. This is the logic we need to implement. So we already have some code that we can reuse here. So I'm not going to type everything by hand. I'm going to copy some code from our other route handlers. So first we want to look up the course, and if it doesn't exist, we want to return a 404 error. For that, I'm going to go to this other route handler where we get a single course. This is the logic we're interested in. So we look up the course, and if it doesn't exist, we return a 404 error. So copy these 2 lines. We're done with the first part. The second part is all about validation. For that, I'm going to go to our post endpoint. So here we need to copy the schema as well as this line for validating the request body using Joy. Now, there is a problem with this approach. The problem is, in this case, we have a very simple schema. What if you were dealing with a complex object with quite a few properties? Then our validation logic would be duplicated in 2 different route handlers. So let's just copy the code for now, and then we'll come back and refactor it to make it better. So copy these few lines and paste it here. So we're validating, and if it's invalid, we need to return a 400 error. So I forgot to copy that line here. If you have an error in the result, we're going to return this 400 error, okay? So let's copy that as well. So this is our second part. We have the schema, we validate, and if we have an error, we return the 400 error. We're done with the second part. Now the third part. So at this point, we have a course object. We can update its properties. So course.name, we set that to request.body.name. And of course, if we have other properties, we'll set them here as well. So we're done with updating the course. And finally, we need to return the updated course to the client. So response.send course. This is how we handle an HTTP put request. Now, I told you that we have duplicated this validation logic. So I'm going to extract these few lines into a separate function that we can reuse both in this route handler for handling our HTTP put requests, as well as the other one we wrote in the last lecture for creating a course. So let's define a function here and call it validate course. We give it a course object. Now in this function, we should have the schema as well as this line for validating the course. So cut these few lines, paste it here. Now instead of validating request.body, we're going to validate the argument that is passed to this method. So that would be the course object. And finally, we can simply return this result to the caller. There's no need to define a constant. So with this new implementation, we have all the validation logic in one place. Now we can reuse this. So here's our put method. We define a constant called result and set it to validate course. And as an argument, we pass request.body. Now we can make this code a little bit cleaner and shorter by using object destructuring feature in modern JavaScript. So look here, we get this result object and we're accessing result.error property in two different places. Since all we're interested in is this error property, we can get this using object destructuring. So let me duplicate this line and show you how object destructuring works. With object destructuring, when declaring a variable or a constant, we add curly braces, and then here we add the property of the target object. So in this case, the target object that is returned from our validate course method has two properties, error and value. In this case, we just want the error property. So we put that between curly braces. So this is equivalent to getting result.error. But instead of using this notation, we use this notation, okay? And with this, we don't have to repeat result.error in two different places. We can simply use error. Okay, so this is object destructuring. Now we don't need this first line anymore. And finally, before we finish this lecture, we need to make one more change in this code. So we need to use this new way of validating a course in the route handler for handling our HTTP post requests. So copy. This is our handler for creating a new course. Now we don't need to use the schema here. We moved all that logic to our validate course function. So all these few lines here for validating the request body and sending the 400 error, I'm going to delete this and paste the code that we copied from the other method. So we call validate course, use object destructuring syntax, and if you have an error, we return the 400 response to the client. Now finally, let's test our new endpoint for updating a course. So back in Postman, we need to change the type of this HTTP request to put, change the URL and add a valid course ID, like one. Here we have a valid course object with name set to new course. So send, and we get a 200 response, which is successful. And here's the updated course. So if you open a new tab and send an HTTP GET request to localhost/API/courses, now you should see the list of our courses. So our first course, its name is updated. Perfect. Now let's test the other scenarios. What if we send an invalid ID? So 10, send the course with the given ID was not found. And you can see the response is 404, which means not found. And finally, what if we send a valid course ID, but an invalid course object? So I'm going to remove the name property. Send. Now you can see we have a bad request or 400 error. And here's the error message. Name is required. Next, I'm going to show you how to handle HTTP delete requests. So out of all the CRUD operations, we have implemented create, read, and update. So in this lecture, I'm going to show you how to respond to HTTP delete requests. It's very simple and similar to what we have done so far. So here's our app object. We call the delete method. Give it a path. That is /API/courses. And of course, we need a parameter because we're working with a specific course. Then our route handler, request and response, goes to the code block. Now here, first we need to look up the course with the given ID. If it doesn't exist, then we need to return 404. Otherwise, we're going to delete it and by convention, return the same course, the course that was deleted. So again, I'm going to borrow some code from our other route handlers. To look up the course and return a 404 error, I'm going to go back to our route handler for the HTTP put request. So these first two lines is for looking up the course and returning a 404 error. So copy these two lines back here. That is our first part. Done. Now to delete a course, first we need to find the index of this course in our courses array. So courses dot index of course. We get the index, store it in a constant, and then we can use the splice method to remove an object from our courses array. So courses dot splice, we go to this index and remove one object. So this is the delete part. And finally, we need to return the response to the client. So response.send this course object. Now let's test this. So back in Postman, let's change put to delete. First, I want to send an invalid course ID, like 10. Send. So we get a 404 error not found with this message. Perfect. Now let's delete the first course with the ID 1. Send. So we get the same course object in the response. And if we go to our second tab, where we have the list of our courses, so look, we have an HTTP GET request to this endpoint. Let's send this one more time. Okay, now look, we don't have our first course anymore. We only have courses with ID 2 and 3. All right, before we go any further, I realized we have a bug, or actually 3 bugs in this code. So look at the handler for responding to put requests to this endpoint. If we don't have a course with the given ID, we return the 404 error to the client. But at this point, we should exit this route handler. Otherwise, the rest of this code will be executed. So the proper way to implement this route handler is like this. So if we don't have this course, we return the response and then exit the function. Or a shorter way to write the same code is to put the return here. And then we don't need a code block, so we can put everything in one line. Okay? Now to make this code cleaner, let's use the same technique in case we have an invalid request. So we simply return, and then we don't need the code block anymore. That's much more elegant. We have the same issue in the handler for delete requests. So if we don't have a course, here we should return immediately. And the same is true when getting a single course. So if we don't have a course with a given ID, we return the 404 error and also return from this function immediately. Now finally, let's have a look at the handler for HTTP post requests. Here it is. Again, I'm going to use the same technique to clean up this code. So if you have an error, we simply return and get rid of the extra noise in the code. That's much better. All right, now it's time for an exercise. So from this lecture, we're going to start building the backend services for our Vidly application. As I told you before, Vidly is an imaginary service for renting out movies. So throughout this course, we're going to build the backend of Vidly bit by bit. Your first task is to create a service for managing the list of genres. So each movie has a genre, like action, horror, whatever. We should have an endpoint for getting the list of all genres, because somewhere in our client applications, perhaps we have a drop-down list for the user to select a genre. So we need an endpoint to get all the genres. We should also be able to create a new genre, as well as update or delete an existing one. So before going any further, I want you to put what you have learned so far in practice. So even if you're an experienced developer, don't say, "No, Mosh, I know how to do this. This is so easy." I know it's easy, but what matters now is that I want you to get used to the syntax. So go ahead, start a new project from scratch, call it Vidly, and build this HTTP service for managing the list of genres. You can see my solution attached to this lecture.